This is Ashfield Park in the centre of Sydney and the site of one of our case studies this week. You can hear and see behind me the traffic on Parramatta Road, and that's the source of pollution in this park. The traffic pollution means there's higher lead concentration in the park close to the road, and it's still quite high where I'm standing a few tens of metres in. So let's find out why there's high lead concentrations in some of the urban parks in Sydney later in this class. This week's topic is soil lead pollution, and it builds on the lead samples that you've collected and will be analysing in the laboratory. Let's start by considering what is Sydney's soil lead pollution. And lead, which has the chemical symbol Pb, is largely derived from traffic and industrial sources. Historically in Sydney, lead would come from leaded petrol and lead in pipes and lead added to paint. Today, the non-exhaust traffic sources are the major source of lead because lead has been removed from petrol. So how does this affect the lead found in soils in Sydney? The input should be decreasing because we removed this source from the traffic. And it should mostly be found in the topsoil because that's where the particulate matter is going to settle. However, as you can see from the figure on the right-hand side, high levels of lead concentration persist in inner city Sydney soils. In the top left-hand corner of the figure, you can see the residential soil lead concentrations measured in the units of milligrams per kilogram of soil, and the highest concentrations you can see are in the inner west suburbs of Sydney. And here, the soil lead concentration exceeds the values that are acceptable. Here's an analysis in the top right of vegetable garden soil. So specifically from the vegetable gardens for these properties. And again, it's the same inner part of Sydney that has the highest lead concentrations and the greatest number of exceedances. So high concentrations of lead persist in inner city Sydney soils. And outside of Sydney, mining and metal manufacturing are also important sources of lead emissions. And lead levels also remain high in some regional towns where they have large industrial point sources. So facilities such as lead smelters, where there's particulates entering the atmosphere, and those particulates would have a high concentration of lead, and then they settle in the soils. Why is it important to consider lead and lead in soils? Well, firstly, lead is harmful to human health. The natural concentration of lead in the air should be less than 0.1 micrograms of lead per cubic meter of air. The national standard in Australia is 0.5 micrograms per cubic meter of air, and concentrations today in Australia are typically much less than that, 10% of the standard. However, that wasn't always the case, and the figure on the right-hand side shows a time series graph for Brisbane. So this is the lead concentrations in the air in Brisbane with the data source from the Queensland government. And the data is a 3-month average concentration of lead in the air. And the units here are in micrograms per cubic meter, so the same units. So you can see here there's a threshold level, which used to be 1.5 micrograms per cubic meter. It's now gone down to 0.5. And you can see two different time series. The blue is a time series that's close to a major road, and the red is close to a suburban area. And the time series starts in 1980, and you can see that before the phase out of leaded petrol, which started to be introduced in the 1990s, there was a relatively consistent and high concentration of lead in the air, and those values would be above the national standard for today of 0.5. And then you can see in the 1980s, unleaded petrol was introduced for the first time. But this wasn't adopted immediately because cars had to be adapted to take unleaded petrol. So the lead content of petrol was only started to be reduced in the 1990s, firstly to 0.4 grams per litre, then down to 0.3 grams per litre, 0.2 grams per litre, and finally in the new millennium, lead petrol was finally phased out. And you can see as soon as we started to decrease the amount of lead in the petrol, then the lead concentration in the air decreased, and the larger decrease was next to the major road because that was closer to the traffic source. And lead is a toxic substance that can affect people of any age. It's particularly harmful to children, pregnant women, and unborn babies, and it accumulates in your body over time. So even a small amount of lead exposure can pose a health hazard as it accumulates over time. A big example of some very scary data as about how much lead affects IQ in 2 slides' time. Traffic sources of lead are still important. Even though it's been removed from petrol, there is still lead present in vehicles. So if you think about a car or a lorry, there's likely to be a lead acid battery in there. Auto paints can still contain some lead, and anti-corrosives that are applied to lorries can also contain lead. So even though we've had this significant decrease in lead in the air since 1986, it hasn't gone to zero. There is still lead present in vehicles. The figure on the right-hand side is taken from a paper of Rangatel, which is another paper from Mark Taylor and the group there at Macquarie University. And Ashfield Park is where I took the introductory video, and I was standing about here, and Parramatta Road is passing just to the northeast. So I was standing here, which is in this zone of relatively high contamination of lead. This is a contamination factor. This is a multiplier of how much higher it is compared to a base level, and you can see it's much higher than the base level. Alternatively, you can look at the distance from the Parramatta Road, and you can see this decrease away from the road, and so you would need to go maybe 100 meters away from the road to get lower lead concentrations in the soil. And again, these are in micrograms per kilogram. These data sets have got a regression line fitted to them, which suggests that you could predict how much lead's in the soil based on the distance from the road. And research has shown that lead contamination in soil declines with distance from the major roads, and that it is correlated with traffic volume. So that is something you might be interested to investigate in the lab class with your data. And lead is still present in some homes as well. And you might think this is a historical thing again, because lead pipes and lead in paint are now not used. But have a think about the age of the home that you live in, or some of your friends or family might live in, and whether they're old enough to still contain some lead in them. So here in Australia, lead pipes were in use until about the 1930s, and then they were replaced by copper pipes. But lead solder to join the pipes together was still used until the 1990s. And lead was used in high concentrations in paint until the 1960s. And then it's now being reduced to very low concentrations. But this source of lead pollution was highlighted by state governments during the COVID pandemic, when people had time to go and work on home renovations, and amateur home renovations for people that didn't realize that there was a health risk there could have led to the removal of very old paint, which still contained lead, producing lots of particulates in the air, which could then be inhaled. So lead contamination is therefore related to building age, with older buildings more likely to have lead paint or lead in the pipes. The figure on the right-hand side is another from Mark Taylor's team at Macquarie University, who's been leading the research on lead contamination and pollution in Sydney. This is a slightly more complicated graph. This shows the lead concentration in the soil, again in micrograms per kilogram. And this is only for an area within 10 kilometres of the CBD in Sydney. by just showing the data from in the city centre, that then takes out the known relationship between distance from the city centre related to the traffic volume. And then the two lines here are the data sets for the houses from this data set that they analysed from over 3,000 different soil samples. And they looked at soil samples from houses that had been painted, which is the green line, and therefore they should potentially have some lead from paint, against houses that were unpainted, which is the orange colour line. And you can see that with property age, lead concentrations were very low, especially for the unpainted houses built in the last 30 years. And as soon as you get to an age of maybe 80 years or older for the houses, so going back to the 1940s and earlier, you start to see increased lead concentrations, but only in the painted houses. So that's telling us it's the paint that's more likely to be a factor compared to the pipes. This is the scary statistic that I mentioned 2 slides back by McFarland et al., who in 2022 published a paper for the United States of America, and they calculated that 90% of the children born in the United States between 1950 and 1981 had blood lead levels higher than US regulations. So this was an early childhood exposure of lead in the homes and to traffic, and they worked out that this cumulative exposure for the whole population resulted in a total loss for the United States population of 824,097,690 IQ points. And that data was as of 2015. So that's the generation that maybe the generation aged of your parents or grandparents or uncles, if you have family members of that age. And they were likely exposed to similar higher lead, irrespective of where they lived. What's happening in class this week? Well, we're back in the lab and we are still considering the analysis of lead in Sydney soils based on the samples that you collected. This week, I'd like to develop hypotheses that could explain the data that you've collected, that would explain the observed lead concentrations. And there's an opportunity to collect additional metadata or ancillary data to be able to test these hypotheses. So the aim of this laboratory class is to introduce you to hypothesis testing and to collect any additional data that would enable these hypotheses to be tested. And your learning outcomes include an understanding of the use of hypotheses and hypothesis testing in the scientific method, and frameworks for collecting and compiling additional data, also called metadata, to enable these to be undertaken. So what do you need to do before the class this week? So this week's class, I'm going to ask you to think about making some hypotheses to test for soil lead concentrations based on the data you've collected. And the best way to build hypotheses is to understand the literature. So what I want you to read are the 2 papers that consider soil lead in Sydney soils. And these are the papers that I took the examples from in the earlier slides. So it's the paper by Wang et al. From 2022, published in Chemisphere, which is the Sydney Parks example, which included Ashfield Park, who I made the video at the start of this presentation. And the paper by Taylor et al. 2021, which is all about their citizen science approach to collect soil samples from across Sydney, which highlighted the role of traffic and house age. That was published in Environmental International. So these are, again, are technical articles written for environmental scientists and environmental chemists, not for a first-year undergraduate class. So again, please don't worry if some of the article is too specialized. Use the reading strategies that I've mentioned before, combined with knowing what you need to understand for the class, which details for which are in the next slide. What would you need to understand before the lab class and for the pre-class test? These are things I want you to understand. I would like you to understand what the typical concentration of lead is in Sydney soils, and that includes making sure you know what the units are. I would like you to understand the relationship between soil lead concentration and traffic emissions. I would like you to understand the relationship between soil, garden, lead concentrations and distance from the CBD in Sydney, and also understand the relationship between soil, lead concentrations in gardens, and the age of the house for Sydney properties. And by understanding all of those, it will allow you to test hypotheses in the class and collect some extra data to see if you can find some interesting relationships between environmental parameters and soil lead concentration.